is Jordan Larson, and this is my junior breakthrough challenge attempt. I go to Northern Cass Public School. I will be in 8th grade, and I'm currently 13 years old. So my topic is Lagrangian Mechanics. Is the title. What is this thing? Well, it's another way to explain classical mechanics. Well, what classical mechanics is simply everyday physics, and that is physics that is not quantum physics or relativity. So why do we use Lagrangian mechanics? Well, it makes very complicated situations much simpler, such as this 4-pendulum system here. So that can get very, very complicated very, very quickly. And it would be very hard to describe this with regular physics quotation marks, but very easy to describe with Lagrangian mechanics. So this is the actual equation, and you can see that this is a differential equation. It's called the Lagrange equations, and you don't need to know what the heck this means. It's just an equation that this is based off of, and L, or the actual Lagrangian, is kinetic energy minus potential energy. Okay, so we know that the kinetic energy of a ball falling to Earth with neglecting air resistance is 1/2 mass times velocity squared, or in this case x dot, and its potential energy is mass times g times height, or x, and so L would be 1/2 mx dot squared minus mgx, or kinetic energy minus potential energy. And so we plug this thing in, and we get simply mx double dot plus mg is equal to 0. And so we can do some algebra to find that F equals ma. Alright, so this is actually Newton's second law. Mass times, so x double dot is acceleration, remember? And so this is freaking Newton's second law, and Lagrangian mechanics is based off of that law, somewhat. So now we're going to derive the kinematics equations, and so we'll use this previous result to get all of this calculus here, and you don't need to know what this means, but we can just do some rearranging here. You get some integrals here, indefinite integrals, and if we set the initial velocity be this stuff here, and we can get the first one, which is velocity is equal to, we can take this as acceleration times time plus initial velocity. That position is equal to this big mess here, and that velocity squared is equal to the initial velocity squared plus blah 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 2x squared to 2ax, sorry, and you have to do some algebra to get this one. It's much trickier than these two. Alright, so in summary, Lagrangian mechanics is cool, useful, interesting, and inspiring. So I highly suggest that you learn some calculus, basic classical physics, and just give this a go. I mean, it's pretty cool. You can calculate a lot of complicated systems. It's pretty cool. So yeah, peace out and be cool. Thank you.